Hello students, this video is for both Math 1B and for geometry. It's lesson 1.1 and it's a pretty basic coverage of something you guys have seen already in previous math classes. You're basically graphing linear equations. I'm going to break some stuff down at a very basic level first so that you guys, if you didn't get it the first time we talked about it in class, it's here for you, and then we'll go through some examples below. Okay? All right, so first question is, you're given all these equations where I say graph them. Like, what's up with them? Y equals 7x plus 2. Y equals 2/5 x minus 3. Y equals negative 4/3 x plus 6. What does it mean? Well, it basically just means this represents a steep line that looks kind of like that. Like if I plug in x values and get y values out of it, they follow this pattern. Something like this would be a more gradual increase. Okay? Something like this would not even be going up, but coming down. And the way we're going to make sense of all that is through this right here. It's called slope-intercept form, which basically means if I get y by itself in each of my equations, and on the other side of the equation, I get a number x, a number x, a number x, plus another number, minus another number, or plus another number, you can use this information to say, my m is always going to be the slope of the line. Slope, okay, right? So here, m is 7, m is 2/5, m is negative 4/3. And a better way to think about that is probably think about slope as your rise over run. Okay? The rise over run is how you plot your points in a specific pattern. So a rise over run of 7 really means it's 7 over 1. Up 7, right 1, plot your point. Up 7, right 1, plot another point. Same thing with 2/5, that means go up 2 units, right 5 units, up 2 units, right 5 units. And then on something like negative 4/3, it means go down 4, right 3, plot a point. Go down 4, right 3, plot a point. So there's the slope part of the slope-intercept. The intercept part is the b value. The b value basically means it's your starting point. It's the place that you first plot your first dot. So the y-intercept is the place where it crosses the y-axis. And if you remember, the y-axis is the vertical up and down one. So that just means start 2 units above the origin. Start 3 units below the origin. Start 6 units above the origin. So that's really what's going on here. The b value is plus 2. The b value is minus 3 here. And the b value is plus 6. All right, so that's a very basic overview of things. Let's actually go through some of these examples and see if seeing things pieced together better. So, example 1 and 2. If we have things in slope-intercept form, then we can basically plot the b and use our m to plot the rest of the points. Let me get this more there. So, right away, we've got y by itself, so that's good news. This is what we want it to look like. The problem is 5 minus 2/3 x does not look like mx plus b. What we have to do is actually rearrange this in such a way that the negative 2/3 x comes first, and then we say the plus 5 comes later. That's the commutative property that allows us to rearrange things that are already on the same side of the equation. So that's definitely something that we are allowed to do. Okay, so based on this, we should be able to determine the slope and the y-intercept. The slope is the m. It's the number in front of x. So negative 2/3 is our rise over the run. Our y-intercept is 5. It just means it's the place where it crosses the y-axis. So we've got enough information to actually move forward on this. Our starting point, our y-intercept, means you go from the origin up 1, 2, 3, 4, 5 units, and then you plot your first point on the line. From there, now we say our slope or our rise over run tells us to plot down 1, 2, right 1, 2, 3. Okay, when you think of fractions that deal with slope, it's always the rise for y over x for run. Rise over run. So, down 2, right 3. Down 2, right 3. And then you've got enough points to plot a line. So grab a straight edge, a ruler, something like that. There you go. Hey, notice something else here. I could have also went up 2, left 1, 2, 3, and that also would have been a legitimate point to plot on the line. So down 2, right 3 is the same as up 2, left 3. These two fractions basically mean the same thing, and they plot the same points that exist on a line like this. So that's kind of cool to be able to do both of those. Let's try number 2 now. So hopefully right away you guys recognize this is in the form that we want it to be. The m is literally already spelled out for us. It's 4/3. The b is, instead of +6, it's -6, so we really have to pay attention that this is a -6, which means it's below the origin to start this thing. So down 1, 2, 3, 4, 5, 6 would be our starting point, our first plotted point on the y-axis. Yeah, and then we go from there. Since they're both positive, it just means you're going up 4 units. 1, 2, 3, 4, and right. Up and right. Up 1, 2, 3, 4, right 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. And I ran out of space, so I'm done plotting points. Okay. So far, so good, maybe? If the answer was yes, then why don't you pause the video and try both number 3 and number 4 on your own. I'll erase this so that you guys can see it more clearly, although it is on your note sheet. Yeah, just hit pause and see if you guys can do number 3 or number 4 on your own. All right. Let's see if you guys were successful or not. Okay, y equals 2 plus 4x. Hopefully from the first example you recognize that, hey, I need to rewrite this as y equals 4x plus 2 using the commutative property, right? Because I need to be y equals mx plus b. This state of things is not y equals mx plus b. Okay, so the m is what's in front of the x, so slope is m equals 4, and we're going to put it over 1 to remind ourselves that it's going to have a rise and a run. Okay? And then our b value is just going to be positive 2. So, start this thing 2 units above the origin on the y-axis. Plot your point. And then from there, the slope tells us I'm going to go up 4 and right 1. Now, I ran out of room right away, but there is one other thing we can do. We actually can say up 4, right 1 creates the same pattern as down 1, 2, 3, 4, left 1. So that's really nifty to be able to do that. Instead of going up 4, right 1, I can go down 4, left 1. And you guys might need a more personal in-class explanation of why this is the case, but just know that you can do that. You can go up 4, right 1, or down 4, left 1. So that gives us enough points to plot this line, and we're done with number 3. On number 4, this one's a little trickier because you've got 2 fractions involved. Keep this in mind, though. The x term has to be written first no matter what, if it's a fraction or if it's not a fraction. So what I want to do is say, to get it to look like y equals mx plus b, I need to rewrite this as y equals positive 3/4 x and then minus 4/5. So what that means is that slope is still 3/4, but my y-intercept is a fraction. It's like a decimal. It's like 4/5 of a block below the origin. Sorry. So here's the origin. What's 4/5 of a block look like? Well, here's a whole block. 4/5 of a block would be right around there. It's more than half. So that's where I'm actually plotting my first point. I'm plotting my first point in between grid blocks. And then from there, I'm going to go up 1, 2, 3 units and write 1, 2, 3, 4 units. And then using the same trick that I did on the previous example, if I run out of room, I can go down 3, left 4. I can go down 3, left 4. I can go down, let's see, I'm going to put some marks in there because it's kind of faded. Down 1, 2, 3, left 1, 2, 3, 4. Still between the blocks, okay? Yeah, and then we take our ruler, we connect the dots here. Not perfect, but it's kind of a faded grid, so we'll chalk it up to that. All right, I got a few more examples. Let's just keep this video rolling. So what are we supposed to do if what are we supposed to do if it seems like it's incomplete? We need y equals mx plus b, but I see y equals mx. Where's the plus b? Well, since nothing's there, we can give the mathematical equivalent to nothing with 0. So if we plus 0, that actually is a legitimate way of representing negative 1/4 x. There's nothing there, so just put a plus 0, which means we start at 0, which is the origin. So that's the first point we plot, right there on the origin. From there, the slope is going to be negative 1/4. Whenever you see a negative out front, that means only the negative is on top or only the negative's on bottom. So I could go down 1, right 1, 2, 3, 4. Or I could go up 1, left 4. And again, it's creating dots on the same line. I'm actually going to split this up into 2 videos because the next section is just special cases and what to do if you're asked to write the equation of the line and not graph it. So I'm going to say see ya, and then part 2 is coming your way on a new video.